So the third video we're going to talk about is about functions being increasing, decreasing, constant, and then max and mins by looking at a graph. So when we look at graphs, we always look at them left to right. And so when we're going left to right, if my function is going up, which means it has a positive slope, we say it's increasing. And if we go left to right where my function is going down, and so we're looking when we go up or down at the y values. So here the y values are increasing, here the y values are decreasing. We say it's decreasing. And when the y values don't change, they stay the same, we say it's a constant. Now, if we have a vertical line, we have an undefined slope. Now that's not a function. So it's not, we don't say it's increasing, decreasing, or constant, and we don't really deal with that, but it's called an undefined slope if we have it. Okay, so if we look at this graph, just as a reminder, this is the graph of the square root of x, that parent function. We want to say, okay, is it increasing or it's decreasing? So if we look at it as we go like left to right, the y values are increasing, we're going up, and so we would say this is an increasing function. Now, most of the time what we're going to do is we're going to have a function that increases and decreases and maybe also constant. And we are going to have to give intervals where the function is increasing, where the function is decreasing. So when we do that, I'm going to do that first before we talk about the maximum. If we're looking at where is the function increasing, when we describe it in terms of the x values. Where is it occurring? And so if we look at my function, we're going to start left to right, all the way to the left, going left to right. It's going up, and it continues to go up until we get to x equals -2. And then at x equals -2, my function starts going down, and so it's decreasing until we get to x equals 2. And then at x equals 2, it turns around and it starts going up again. The y values are going up, and so it's increasing. So we will say it's increasing based on, again, the x value. So because it has an arrow, we're going to assume it keeps going to the left, which is -infinity. And we always put parentheses. So we would say it's increasing from -infinity until we get to this x value of -2. And then we're going to put a parenthesis. And we always put a parenthesis because at this point, my function is neither increasing or decreasing. It's considered constant just at that point for a moment. And then we're going to put a u. And the next place that it starts increasing is here, and that x value is 2. So again, always parentheses, and then it keeps increasing after 2 for all of the positive x values. So we're going to put to positive infinity. So then for decreasing, we're going to say, okay, it starts decreasing at -2. So we put parentheses -2, and it continues to decrease until we get to this point, which is 2. And so that's how we would write the intervals where it's increasing or decreasing. Now, we have some other features called max or mins, and another name for them is local extrema. So anytime they say find the local extrema, that means that they're asking you to find the local max and mins. So a local max, also known as a relative max, is a point where a function changes from increasing to decreasing. And it's also the highest point in that region. It might not be the highest point on the entire graph, but it's the highest point locally, like around it. The local min is the point where the function changes from decreasing to increasing. So here is a local min. Here is a local max. And again, another name for a local min is relative min. Now, for the local max and local min, they might ask you where is it, or they might ask you what is the local max or min. So if they say where, you give the x value. So the local max occurs at, or where it is at x equals -2. If they say what is the local max, what is the value, we would give the y value. So the local max value is y equals 16. Okay. Same thing with the min. If they say where is the min, we give the x value. So the min occurs at x equals 2. If they say what is the local min, we give the y value, which is y equals -16. And often they might not ask you to put x and y, they might just say, what's the local min? And you would just say -16. And what's the local max? You would just say 16. Now, the highest local min is called the highest local max is called an absolute max. Okay, and so the absolute max is the highest point on the entire graph. Now, some graphs, like this one, do not have an absolute max or min, because this arrow means it goes up forever, and so that it has no max. This arrow means it goes down forever, so it has no min. But if my graph has endpoints, then it definitely has a max or min, which means it stops and there's not errors. You will have an absolute max and an absolute min. And some functions that don't have arrows will have either an absolute max or an absolute min. So in this case, the absolute max, okay, is 2 is the y value at x equals 2. So I'm going to write it that. And the absolute min is the lowest point on the entire graph. Okay, and again, we're always looking at the y value for this when we're talking about max and min. So if I look up and down, the lowest y value occurs here. And so the absolute min is -2 at x equals that x value is 0. And sometimes, again, you write it as a point, or if they say where, give the x value. If they say what is it, then you give the y value. Okay, so the last thing we're going to do is we're going to use our graphing calculator to find the local extrema, which again means the local max or min, and to estimate the intervals where the function is increasing and decreasing. Okay, so on our calculator, we're going to go to y equals, and we're going to type in that function. So you're going to type in x to the 4th minus 4x cubed plus 5. Okay. So then we're going to graph it. So one thing is, the first thing I tried was zoom fit, and I wouldn't recommend that because you're not going to see the full picture. It's actually very zoomed out, and so you can't see. So in this instead, I would go to zoom standard, so Z6, which will give you a 10 by 10 window. But you can see here, I can't see the entire function. So I'm going to go to window, and going back, I need my graph to be lower. So I need to see more y values as we go down, which means when I go to window, I need to make the y min a lower number, which means a more negative number. So I'm going to change it to like -20 and then hit graph. And it went down, but I still can't see the lowest point. So I'm going to go back to window, and I'm going to change it to like -30. And you can do more extreme, you can do -50. But I want to be able to see like the lowest point on the function. And if you go to window, you don't have to, but if I make the y max higher, just to make sure that it continues to go up, I can see that it keeps going up. Okay, so this gives me an idea of what my function looks like. So then I want to figure out the local extrema and then increasing and decreasing. And so the first thing I have to find is the local extrema to figure out where my function is increasing and decreasing. So I'm going to do second calc, and I'm going to find, in this case, I only have a minimum. So we're going to go to minimum. I can see I don't have any max. And we do left bound. So we're going to go to the left of it somewhere, hit enter. Right bound means I'm going to go to the right of the min and then hit enter. And then I'm going to hit enter again to get the actual minimum. And whenever you see like 2.99999, that just means round it to 3. So the minimum occurs, and I'm going to write it as a point, at 3 -22. So this is both a local min, and this is also the absolute min. Okay, so every absolute min is also a local min. It's not the other way around. But this is the lowest point on the entire graph, so it's an absolute min, but every absolute min is also a local min. Okay, so that's the only max or min. And so then from there, I'm gonna say where my function is increasing and decreasing. Okay, so my function is decreasing. And technically it levels out here and is constant for 1 minute and then it keeps decreasing. But we're not gonna So we're not gonna worry too much about that, but if you wanted to find it, it kind of levels off. And so it's technically constant there, and I can tell it occurs at x equals 0. So to find the value, I can like do second calc, go to value and put in 0, and then this point is where the function is constant for a minute. So it's not technically increasing or decreasing there. But then the other point where it changes from decreasing to increasing is at x equals 3, which we found from the max. So what we could say is my function is decreasing from negative infinity until we get to that 3. And so that's fine for this class. When you get to calculus, you would probably be a little bit more specific and not include this x equals 0. But for this class, you can just say that it's decreasing from negative infinity until you get to 3, and then it's increasing after 3. So we would say it's increasing from 3 to infinity. Okay. But another acceptable answer, if you wanted to include that 0, is you could say negative infinity to 0, union 0 to 3, for where it's actually decreasing, because at x equals 0, it's not decreasing. But like I said, I will accept this answer, and then when you get to calculus, you will probably have to be more specific about it. Okay. But the main thing is that when you're trying to find increasing and decreasing from a graph, you graph it on your calculator and you find the max or mins, and then your function will change from increasing to decreasing then. Okay, so those are the 3 topics for 1.3, and then we'll practice with them.